Yeah, hello friends. This is Tabish Mendi, and welcome to my YouTube channel. So today, I am going to discuss about a very important topic, which is capacity planning. So capacity planning is one of the very important topic of the system design. So in this particular topic, we are going to discuss about this only. So why we need to do this? First of all, we need to understand that thing. If you're going to create any product or system, you need to estimate something, uh, some features, you need to estimate, like how many users can come to your platform, how many user can access your features at the same time, how many read write operations can be there, what could be the total storage per month, per day, or per year basis, or during the peak time, how your system going to uh, handle all those requests without any downtime. So these are some very important key factor which we need to estimate beforehand. And after doing those estimation, we need to what are the planning we have done. We need to show those planning to our client, and based on our planning only the client going to accept or reject, or provide their feedback, and accordingly we need to design our infrastructure. So this is very important for any software development, or any agentic or RAG application or JNE application, if we are going to build. So capacity planning is the first step uh, before we are going to develop any infrastructure or any product. So in this video, I'm going to uh, define the capacity planning of a very uh, familiar platform, which is YouTube. We all aware about it, and since YouTube is a globally known platform, and it has billions of users and active users every day. So we are not going to define the billions of users, but we are going to define if 10 million users per day coming to our platform, so how the system will look like, what will the total storage uh, will be associated with it, what is the daily cost, monthly cost, or yearly cost will be there with respect to the 10 million users. So that's what we are going to see in this particular video. So let's do it. Okay. So before going, we need to do some assumptions like how many daily active users can come to our platform. So here we have doing the assumption like 10 million users can come to our platform every day. Since YouTube is based on totally on videos, upload, download, streaming. So based on that only we are going to do some assumptions. So this is DAU, which is daily active users, which is could be at 10 million. Uh, we are doing the estimation. So videos uploaded per day. This how many videos can be uploaded per day. We have estimated like 5 lakh videos we are estimating can be uploaded per day. What could be the average video size which has could be uploaded? So it could be 500 MB we are estimating. What could be the video total video duration? So 10 minutes we are doing estimating the average video duration. Replication factor, it is 3. Suppose we are going to uh, uh, upload our or deploy our application. So we have estimated like 3 replicas of our application will be uploaded to the 3 different servers. So if one server is down, then the video can be streamed from the uh, another 2 servers. During the peak hour, what could be the, so we have estimating the 5x multipliers, and average video watched per day by per user. So we are estimating that every user going to watch 5 videos per day. So these are some assumptions which we have made over there. So next we need to see what will the total storage will come if we are doing the upload. So we are like we have did the estimate like we are doing the 5 lakh uploads per day, and the average size of the video will be 500 MB. So just we are calculating the same. The videos upload into average video size will give the daily video uploads storage. So that will be around 250 TB per day. This 250 TB per day will be required uh, uh, to store the videos which are going to be uploaded on our platform. So 250 TB per day will be required. Now, so if you are going to upload those videos, so in the YouTube we have seen like we have different resolutions like 250 pixel, 360 pixel, 480, 720, and 1080. So if you are going to upload a 500 MB videos, so these 500 MB videos like will be watched from different internet speed and different uh, platform like a mobile or desktop or laptop. So suppose if you are going to upload 500 MB of video, so we will require 1.1 GB of storage for uploading the 500 MB video. So if you see, every video is transcoded into 5 resolution variant to serve all device type and network conditions. So if you have a very good internet condition, then 1080 pixel will be watched, and the total consumption will be 500 MB. So we need to store the different resolution type, and for that one we need 1.1 GB of video, 1.1 GB of storage per video. That what we have calculated. So uploading one video of 500 MB, we required 1.1 GB of space. So this is the one thing, and we need to calculate the daily storage. So since we are uploading 5 lakh video per day, and the storage per video is coming like 1.1 GB. So daily means daily storage will be required like 550 TB per day. So this is the 550 TB per day will be required for daily storage, and so we can calculate the annually in the same way. Like we can just multiply 365 into this 550 TB, so we will get 201 PB per year. And during the peak hours, so we can multiply into 3, so 603 PB per year. So it, what it is reflecting that if you are going to develop our system, so this much of space we need to require per year to serve our users. If you are not going to do it, then our system can fail or any downtime can be occur. So this is the minimum storage will be required per year for our platform. So that's what we have written. Storage requirements 603 PB per year. That can be round off into the 600. Now this is a streaming. Like suppose that part we have done for the uploading of our video. Now we have the video and we are going to watch the videos, right? So how the streaming will work? So as we have already estimated in the first section, we have made the assumption like every user going to watch 5 videos per day. This is our assumption. So based on our assumptions, we are going to calculate the streaming part as well. So daily views. So daily views means how many users we have. We have 10 million users, and every user going to watch 5 videos. So it will be 15 million views per day. 15 million users per day. That the views we will have per day. So and suppose this is the average view. So and every video will come with a different size. Some video can be long, some video can be short. So we are estimating that we are going to watch 300 MB of average size of a video with 720 pixel baseline. This is the pixel we have estimated, and average size of the video we are going to watch, the user going to watch, is 300 MB. So this is the assumption which we have made. So 50,000 views per day. Okay. So we are going to estimate how many streams data transfer will be required. So 5 million into 300. So that coming to by multiplying, we are getting this much of MB of data. So if you are going to convert into the PB, so we are getting 14 to 15 PB per day. So this much of data transfer will be required for the streaming purpose. So if you are going to convert into the TPS, this 15 PB convert to bits, so it will bits. So we are going to get this much of value, and after converting further, we are getting 1.5 TBS average streaming bandwidth. So this is the average speeding bandwidth which is coming, and during the peak hour, we are just multiplying with 5. So 7.5 TBS bandwidth will be required uh, to infrastructure support will be required. Means 7.5 Tbps infrastructure will be required for the user. Now, here we are going to calculate the CDN. So before going to the CDN, first we need to know what is actually the CDN. So for that one, I have just created one small diagram over here, just to understand what is CDN. Suppose I am in India and my application has stored into the Mumbai region. This is in the Mumbai region. I have a server, and my application, the YouTube, has been stored in the Mumbai server. Now there is one user who is in US, and he wants to means use my application. So what it will do, it will make when he make a request. So first time the request comes, when you make first time request, so that request coming directly to the, wait a second. Okay, let it be. So first time when a user from the US make a request, so that request directly come to the Mumbai server, because main application has stored in the Mumbai region. And once this gets served, so we have using the CDN. So what the CDN will do, what are the content he has used from the server, all those content get cached into the nearby location or nearby server, which suppose it is in the Virginia. So what are the content they have used in the Mumbai region, all those content get cached into the Virginia, which is nearby location to that particular user. So next time if we are going to uh, uh, use the same content, so he's not going to use the Mumbai server. He's going to use means all the app, the content will be will be served from this Virginia server, not from the Mumbai server. So this is the CDN, means all the content which is the Mumbai server will get cached to the nearby location to the particular user. So in this way, what we used to do, It will help in the latency, means user will have a very good user experience. uh, the latency get also reduced. And what uh, this is the main functionality. So it will not get served directly from the Mumbai server. Whatever the user wants, the content wants, it get directly served from this CDN, which is located in the 1 GB. So this is the use of this CDN. That's why we use it. Now let's back to our CDN. So since we already see why we use CDN, so we need to understand now how the traffic flows, and what will be the cost associated with it. So we have already estimated like 15 PB per day data stream will be required. So we are estimating that the CDN will serve the user request 95% of the time. So 15 PB per day into 95, so 14.25 PB per day will be served directly with the CDN, and remaining 5% will be served from the original traffic, which is the Mumbai server. So this is the overall the CDN traffic CDN calculation which we have done. Now we need to do the infrastructure and the cost estimation. So as we already did, estimated 600 PB, like we have estimated over here like 603 PB storage requirement will be required. So if you are going to do the rounded, it will around 600 PB per year. So monthly it will be required 50 PB per year. So that's what we have written over here. If you see 50 PB, 50 PB per month will be required. So the cost, suppose 1 GB is costing around $0.02. So it will be around uh, $1 million per month for the storage per month. And for the same, like 450 PB, like we have estimated like 15 PB will be required per month. Here 15 PB per day will be required for the CDN traffic. So uh, the annual cost will be around 15 into 30, it will be around 450 PB. 450 PB will be required, and if we estimate that the per GB cost is around 0.02, so total cost of the CDN will be 9 million per month. 9 million. So if we calculate these two, it will be around coming around 10 million per month. And some CDN bandwidth cost, storage cost, and this metadata cost, if we add, so it will come around 13.5 million per month. Suppose we have estimated only for 10 million users, and for the 10 million users, it is giving a 13.5 million per month. So C means for 1 billion user, because WhatsApp and YouTube, like for YouTube, to almost serve more than 1 billion user every day, and we have estimated only for the 10 million. So you can estimate how costly it is. So that's what we have estimated the cost over here. And YouTube also, some AI/ML users also, they used to do like video processing. They used to attach thumbnail, spam detection, copyright detection, um, the recommendation engine. So these kind of AI/ML users are also done by the YouTube. Ads filtering, click through rate, all these done by the AI/ML. So this is the overall. If you see, this is the final capacity planning which we have did. Uh, Upload per day like 500K, daily views 50 million, a daily transfer 15 PB for the CDN, Average bandwidth is 1.5. For the peak hours, it will be 7.5. CDN traffic 14.25. So you can see this is the final capacity summary which we had done above. So this is the way we used to do the capacity planning for the system which we are going to build. Uh, if we have all this data in our hand beforehand, if we have all this data, so it will be very easy to build our infrastructure, and we can serve our users with almost zero. I cannot say it will be zero downtime, but 99% of time, like out of 199 time, user will not face any issue. So if you are going to do a proper capacity planning, so we can serve better, we can serve users, um, and the user will feel happy about your product and your services. So yeah, if you feel like you have learned something and you get some idea about this capacity planning, so please write your comment in the comment box, and I will, and please subscribe and uh, give your views in the comment. Thank you so much.